All right, hello again, everybody. Welcome back to Airbus 320 Tech Talk. What do all those buttons do? Thank you again for joining me. I am out on an overnight in New Orleans right now, and we are going to pick up and continue our discussion where we left it off last time. So the next panel that we have to tackle today is the air conditioning portion of the overhead here. And what I was kind of thinking about when I sat down to plan this discussion out, I mean, we could go into so much depth and detail because this air conditioning panel kind of touches a lot of other systems, and I'm going to try to keep it condensed and keep it focused today for you. So I'm going to try to do my best to not go down a rabbit hole and talk about too many different things, but I want to just kind of keep it, like I said, focused on the air conditioning, panel and system, specifically on the aircraft. So I'll do my best to do that for you. So we'll talk about the aircraft, or the AC system rather itself, just kind of an overview. And I want to talk a little bit about the packs, because those are something that's really important to this air conditioning system. And I feel like a lot of folks are really kind of confused about this, and it took me a while, honestly, to when I was learning about aircraft systems, to try to get a grasp on it. So I'll do my best job to kind of just give you some general information about that, and we'll talk about some of the cooling modes on the Airbus, because they are kind of unique, and we'll take a look at the cockpit displays and what we look at in the flight deck, and we'll of course talk about the buttons and the lights, and we'll wrap it up with the kind of the questions section. I'll kind of revisit some of the electrical talk that we had last time. So let's kind of jump in and talk about, like I said, just the air conditioning system in general. Let's pull up and take a look at this graphic while I'm talking here. Once again, kind of a busy, pictorial depiction of, several of the components and the AC system on the airplane. But I just want to kind of point out just a few general things. We have these packs, or they're pressurization and air conditioning units that do just as they say, and they provide the cool air that goes into the cabin, and of course the pressurization itself. Very basic general principles here is we take hot bleed air off the engines, and we route them through these packs, and we kind of cool the air down, and we send them out to this mixing unit that basically recirculates cabin air back into this kind of centralized mixing area, like we said here. And then there's also on the Airbus, there's this hot air with these trim air valve system that kind of allows you to do some fine tuning with the temperature of the air that actually finally goes into the various zones throughout the cabin of the aircraft there. And of course we have three zones. We have the cockpit, the forward and the aft section on the 320. And one of the things that really struck me when I was looking at this graphic, I think this is really funny. I'm not sure, once again, why Airbus decided to do that, but just the color coding to me doesn't really make a lot of sense. So you have this red section that's the final conditioned air that's routed into each section of the the airplane there. But something to point out is really they probably should have made all this section here the red one, because this is kind of the hot air kind of coming through the system, and then the blue of course indicates cooler air going in the system. Then I would have thought they would have had just green, nice color nice temperature air going into the cabin there, but just a really random observation. So if you're looking at this and kind of confused by that as I was, just I wanted to point that out to you. But like I said, the hot air comes out of the engines, goes through the packs, it gets cooled down, it gets mixed up, and then there's this system here where once we can kind of make it the exact temperature that we want to feed into the various sections of the cabin there. And that is very generally how we accomplish cooling the inside of the airplane. Like I said, I wanted to kind of talk a little bit about this pack unit and how it works, because I think it's a very ingenious system. And it does differ, a little bit, from the way that a car, gets its cool air to do its air conditioning. And like I said, just some very general high-level concept, stuff here. I mean, this all, a lot of what the pack does to get cool air out of it, anyways, all has to do with this physics principle about the expansion and compression of gases. And generally speaking, when you compress a gas, you heat it up. When you expand it, it cools off. And this is the exact principle that's kind of utilized in the pack. So, once again, the high pressure, hot, air bleed air comes out of the engine, and it goes through, the first section of the pack here, where it runs over this heat exchanger where, some of the heat is extracted. and then it routes through this compressor section where it gets further compressed, and that air is then routed again over another portion of the heat exchanger, so we take more heat off, and then it kind of twists its way around and makes its way through this this turbine expansion chamber where the gas is allowed to expand, like we said, and becomes very cool at this point, and then it gets routed out into the section of the pack where the cool air comes out of, and like we said, kind of feeds into the system there. So that is a very general, like high-level concept. These things are probably a little more complicated if you're actually to like sit down and dissect one, take one apart. I think there's some more technical nuances that you could probably discuss there, but that's way over the comprehension of most of us pilots out on the line. Obviously, we're not mechanics once again, but just like I said, having this general understanding of what it's doing in there and how it's functioning is all that is really important to us. When we're out there flying around and operating these things. And one other interesting thing I wanted to kind of point out, it's depicted in this graphic here, but we have there's these ram air inlet sections on the front of the airplane, and I'm going to pull up a photo of an A320 just to show you what those look like. And these actually do differ. We're going to talk a little bit further in the discussion about there is a standalone ram air intake valve that's used for something different, but like we said, there's these little forward sections of on the belly of the airplane where this the air kind of comes in and is allowed to pass over these heat exchangers, and like we said, extract that heat off the the hot section of the air that's passing through all these pipes here, and then it actually gets blown out like kind of the underside of the belly. And I wanted to show you a picture of that because you might be curious about just what these things are. And that's just this little NACA scoop here. That's all that inlet valve is there for. And it's kind of confusing too. You might think to yourself, well, is outside air really being intaked like through this little section here to make its way into the whole AC in the cabin? And well, it's not necessarily what it's there for. Like we said, it's just more for the cooling of the pack, or the just that whole business about all that air passing through that section of the system there. So just wanted to point that out to you guys. Let's go ahead, and I want to bring this graphic up again and talk about just a few more things. So like we said, on the Airbus, we have something called, there's these different modes of cooling. We have something called basic, and we have this optimized cooling system. And the optimized one is, of course, like the normal way that we cool the airplane down. And what this optimized business is all about is it's kind of a way to fine tune everything that's going on inside the cabin there. You can actually command different temperatures and different zones. Because maybe one section of the airplane is a little bit hotter, maybe there's more people sitting back there as opposed to a forward section of the airplane that has less people. So you kind of, you're doing this little bit of fine tuning to keep everybody comfortable, in their various areas of the aircraft, and that is actually regulated and controlled by these trim air valves here. And to talk a little bit more about this trim air valve system, the way to think about this is, picture like the sink on your in your bathroom, or your kitchen sink or whatever, or a bathtub even, where you have like a hot and a cold knob. And this system is like, let's say that you were, you had the the cold output of the water, set to wherever it was set from, because that's what was demanded by the system, for whatever reason. And that hot knob could then be kind of twisted and add a little bit more hot water to the system, a little bit more, take a little bit out, and kind of regulate it to get the final temperature that you're actually feeling, like on your your skin if you're holding your hands out or you're taking a shower, or like we said, you're running your hand underneath the bath water there. So that's kind of the analogy of the way to think about like what these hot trim air valves are doing for you. And once again, if you just follow the routing, I mean, this is just hot air that's coming off of the bleed section there, and it's allowed to kind of mix into the system there. So hopefully that makes sense to you guys. Now, if for whatever reason this this hot air valve here decided that the system was overheating, or it closed, or it failed, or any number of things, well, then we kind of drop down to this basic level or basic mode of cooling, or temperature regulation. And that very simply just, the plane just looks at, whatever the lowest demanded temperature is. So whatever you've set, at the lowest, point on these knobs over here, it's just going to command the packs to output the same temperature across the system. And then theoretically the plane is just kind of allowed to, the environment inside will just kind of mix up the air, and it's going to naturally circulate, just the way it does. And you of course have this basic mode of cooling. And one other thing I wanted to talk back about too, like back to our optimized scenario there. I mean, we can make a temperature selection in the flight deck, but the flight attendants actually have the ability on their panel to kind of regulate. I want to say it's within I think it's like a 6 or 8 degree margin or something. I'd have to go back and look that up for you guys, but there is some sort of tolerance that it's like, we can say, hey, we're commanding, this temperature of air to go into the cabin, and they can, from there kind of fine tune it and have a little bit of control, up and down about what they want the actual temperature to be. And this, of course, makes a lot of sense because, on other airplanes I've flown, it's been really frustrating because the flight attendants didn't have the ability to do this in the back. So they were constantly calling up front, and, it becomes kind of an annoyance after a while. You're just trying to, concentrate on flying the plane or do what we're doing. And you're just constantly having to, fine tune the knob and trying to get everybody comfortable in the back. So it's actually just a nice thing that they have the ability to kind of do a little bit of regulation, on their own accord for whatever, they determine is needed back there. And it's just a brilliant part of the system. So let's talk next about just some of the indications that we see up in the flight deck. I mean, these are the status displays, and oops, not that one. I'll talk about that later. So just want to show you guys what it looks like. I mean, normally when we're cruising around, actually on the general cruise page, which is the one that just stays up for the entirety of the, just as you guessed, the cruise portion of the flight, we have this little depiction down here of what each zone is doing. So cockpit forward and aft, what the temperatures are in each section there. And then if you wanted to go onto the air conditioning page itself, it has a little bit more synoptic information. And this just kind of shows us a little bit more about the status, once again, of that hot air valve itself. And these are actually the trim air valves, what they're commanding. And, you can kind of see these temperatures here. They just tell us, the output of the system. But the number up here actually tells us the actual temperature that the cockpit is right now, for example. So, in this, scenario, let's try to break down a little bit more. I mean, maybe the cockpit is 74 degrees and we've determined, hey, we're a little bit cold. So we reach up in the overhead, you turn the knob up a little bit. The system then says, okay, well, I'm going to put out 88 degree air until I reach, that desired temperature, of whatever they're commanding. So you can kind of see, exactly what the system is doing for you. So hopefully that makes sense. And this graphic's actually kind of good because we have a contrast here about, what each zone is outputting and what each zone is specifically indicating at the point in time. So you can see in the aft here, the system is happy, so to speak, because they've, commanded, probably a 72 degree temperature. So the output is 72 degrees and the actual, temperature of the zone of the airplane is 72 degrees. And these ones, once again, they kind of differ. The air being put out is slightly different in the actual indication here. And, once again, this is kind of a brilliant part of the system with it all being automatic. I mean, we're not having to constantly, manipulate things. I mean, we just set the knob to where we want it, and then the system kind of uses, all the available means to kind of, continue to meet that temperature demand, whatever it's being asked to do. So hopefully that makes sense to you guys. Let me know if you have questions about that, but that is kind of the basic overview there. So next, we'll go ahead and talk about the buttons and the indications on the flight deck. So, let's talk about each one of these knobs here. First of all, starting on the left here, we have this pack flow knob here, and this just allows us to kind of regulate the amount of air passing through the system. And the best analogy that I could tell you guys with this one is, let's think about how it is on your car. Let's say you get in and you're just by yourself and you don't want the fans and all the air to be being blown through the cabin of the car. You just don't need the max output kind of thing. So you might kind of put it on medium, or in this case normal. And it just in the same way that scenario varies, it varies the same with the airplane. And the training that we have is that basically on the A320, we'll go to the low pack flow selection here, and we have less than 115 guests. We just don't need the system to work as hard, so we can turn the switch to the low position there. Anything above that, we'll just leave it in norm or normal. And the high mode is actually for different situations. If we're trying to clear like smoke and fumes out of the flight deck is one possible scenario. If we're operating in a hot and humid environment, we just need more air moving through there, we can do that. And I think there's one or two other scenarios. I'm kind of blanking off the top of my head, but those are the first ones that come to mind. But just like I said, a little bit of regulation that we have, as far as the air throughput, in the system. The next three knobs here are pretty self-explanatory. It's just the hot, cold, the temperature selection for each of the zones. I don't know why Airbus didn't actually put the actual temperatures on these little marks on the knobs themselves. I think that would probably be really helpful. But of course, like as you'd imagine, after operating the thing for for a while, you kind of get used to like what knob position corresponds to like what temperature makes you comfortable. But very specifically, it's a range of 18 degrees Celsius to 30 degrees Celsius, and right at the top, the 12 o'clock position is 24 degrees Celsius. And you just kind of get used to like where these knobs tend to live. And I can just tell you guys, for very general purposes, the cockpit knob usually stays at about the 12 o'clock position, and then at least when we're cruising around, anyways, in the forward cabin, the aft cabin usually stay at this, somewhere between the, around the 10 o'clock position here. It just seems to be what's generally normal, nice, comfortable temperatures that everybody likes to be at. So those are what those knobs do there. While I've got this slide up, I'll go ahead and talk about the cross bleed section here. So the next one, I'll bring up the slide with all the lights on and everything, so you can see what those look like. But the cross bleed knob here just allows us to, just as the name implies, allow for some bleed air to go across the system for different things that we might need to be doing. The only thing the auto mode does for us is it allows for the system to allow air to both sides if we're using the Apu Bleed. So if you reach up and you turn on the Apu Bleed button itself, it's going to open up the Apu Bleed and allow bleed air through the system. The cross bleed will automatically open, and it's going to supply air to both the packs on the left and right side, or pack 1 and pack 2. If you close it, the same thing happens in reverse. The valve shuts off, and like I said, that's pretty much what the auto position is there for. The open position, we use that when we're actually cross bleed starting an engine. So if we want to use bleed air from one side of the system to start the opposing engine, there's a book procedure that we actually run through to make sure everything's configured correctly, but we would just manually move this switch over into the open position, and we could allow for, like we said, an engine to be started from the opposite side's bleed air if maybe the APU is inoperative, and that would be one reason we would need to do that. So that's what that is there for. In the shut condition, or the shut portion of the switch there, I think it's more for, obviously if you're trying to isolate one side of the system from the other, but I think it's mostly there for, let's say if you have a condition of like an overheat, type of thing coming out of one of the bleeds, and there's a problem, like we said, shutting off that airflow to the other side of the system. I believe that's one scenario you would use that for, but I haven't really come across this a lot. We never, like in our normal, day-to-day operations, like use that shut position there. So but that is the explanation of why it's there. So let's go ahead and bring up the next slide here and talk about just the lights and the indications and different things we might see. So once again, on the hot air section here, we kind of talked a little bit about that valve itself. This is just the push button switch, of course, left in, big surprise. It's in the auto mode. If you push it out, you'll get the off light indicated, and it would close that valve, and the fault light there would just tell you that there is an overheat in the hot air system there, and you would get an ECAM caution as well with this, and that is what that is there for. The pack switches also, once again, always generally stay in the pushed in or the auto position. If you wanted to turn the pack off, you could use the switch to do that, and of course you'd see the off light. And the pack fault light itself, it's got kind of a handful of conditions that will cause the fault light to come on. And actually, I was thinking of actually the bleed switch, but just the I wanted to make sure I'm saying this right. The fault light on the pack switch there will illuminate when the pack flow control valve position disagrees with the selected position, or if the compressor outlet overheats. So kind of some gee-whiz information for you there. The engine bleed fault lights, though, like we said, just, normal auto, pushed in, off, pushed out kind of stuff. We could turn it off manually if we needed to. And the fault lights there, those are the ones, I'm sorry, guys, that has a few more conditions that are a little bit more technical. So just to, once again, right out of the book, the fault light and the bleed push button there will illuminate for an overpressure downstream of the bleed valve, a bleed overheat, wing or engine leak on associated side. Bleed valve is not closed during engine start, and bleed valve not closed with the APU bleed on. So those are those faults there. The APU bleed push button, once again, it does not have an auto mode. That is indicated, kind of by, the blue light here. This is actually kind of interesting. Something I've noticed about the flight deck is all the buttons that don't have an auto mode will kind of follow this kind of color convention. So kind of an easy thing if you've paid attention as we've kind of stepped along through everything. That is an interesting thing to point out. I just thought to mention right now, but very simply, it just opens and closes the APU bleed valve as desired. And the fault light there, if we have an APU bleed overheat, that will come on with an ECAM as well. And the last one, the ram air switch here, like we said, this is kind of a special one, and it did differ from those ram air NACA scoop inlets that we talked about a moment ago. This ram air system is there for the condition of if we had some kind of smoke or fumes accumulating inside the flight deck, and part of our emergency procedures required us to get that smoke and fumes out of there in an expeditious fashion, because it's obviously probably a dangerous situation if it's getting to the point where we're having a hard time breathing, we might have a hard time seeing. I mean, this is kind of a let's say like maybe a last step, like drastic measure to kind of allow for a whole lot of outside air to be passed like through the flight or the cabin rather, and in hopes of clearing that out. And this is of course part of a QRH or an ECAM procedure that this would be manipulated. And of course, if you notice, it's a guarded switch. We've talked about those a bunch of times now, so it needs to be confirmed before we switch it. But the best analogy that I could tell you to think about for this one is this ram air switch there is just like, obviously in an airplane you can't like roll down a window like you would in your car, but let's say there was something burning up inside your car when you're driving down the road. Well, hey, you want to evacuate that bad air that's in there as quickly as possible, so you're going to roll down your window. Well, you obviously can't do that in an airplane because of the the aerodynamics and the speed we're moving at and all the kind of things that are going on outside of the airplane we're flying around. So that's like what this system is there to do. Like I said, it's just kind of a way to, like, if you need to like crack the window and roll it down and accomplish something by doing so, that is what that ram air system is there for. So like I said, hopefully that makes sense to you guys. So that pretty much wraps up everything I wanted to tell you guys about the air conditioning system. If you have any questions about that, don't be afraid to leave them down in the comment section there, and we'll kind of talk about them a little bit more. So the Q&A section here, I wanted to kind of wrap up and talk about, once again, Abby Thomas, once again, thank you for watching. Had written in with a few more questions, so I'm going to try to tackle a few of them, as I kind of shortchanged you guys, I feel like, on the last video, because I wasn't able to take a picture because I wasn't at work one of those days. But I just want to kind of talk about a little bit more about some of the depictions on that electrical Synoptic page, as he had some specific questions about that. And before I do that, I took a video. So if you watched the last segment as well, we kind of talked about one of the interesting things I thought about the Airbus was just this really loud, like clunking, like very pronounced, like switching of relays that occurs. So I took a short video, and hopefully you can hear the sound on here. It doesn't quite capture the moment or do it justice, I guess you would say, if you're actually sitting there. But it kind of gives you an idea of what I was talking about. You hear this like very loud, like pronounced, like clunky noise when you change relays over in the airplane. So I'm going to play it a couple of times for you guys. So you can hear what I was talking about in the last video there. So let's try to bring this up and see if it works. All right, one more time. All right, so you get the idea, but you can see like all the lights are like flickering. You hear that loud noise, and you certainly feel it if you're setting up there. It's just kind of an interesting thing that, like I said, I haven't seen in a lot of other airplanes. But let's go ahead and talk about some of the questions that Abby had there, and bring up the right slide first, you guys. So coming back and taking a look at the electrical synoptic page here right out of the aircraft. So this is us, like we're sitting at the gate. We have the electrical power plugged in. So that's what you can see is feeding the whole network on the airplane. And this is kind of like an interesting point in time because the APU is actually up and running and the generator is on and available. As you can see, it's outputting power essentially. But what you notice here, there's no line, of course, that connects it to the system. So we know it's not doing anything for us. But one of the other things to point out here is the 0% indication here. And this is like one of the questions that Abby had about like, what does this mean exactly? And that's actually the load that the system is using, like of the available output from that generator. So we can see here, once again, the generator is actually running, but the system is not putting any load on it. So therefore, you have a 0%. So it's kind of like, you know, the plane knows like, hey, this is how much I can give you in power output, and this is how much you're asking of me to do. So it's kind of a, you know, just a depiction for us to be aware of, like what the, you know, are we overloading this unit? Is there something going wrong, or is everything normal and it's staying all green and we're just in our normal ranges of operation? I mean, that's specifically what it's telling us here. And you can kind of contrast that also, you know, Gen 1 and Gen 2 are off because the engines aren't running, so we have no indications about a voltage and a frequency output. And of course, there's no load on the generator there, so the 0%. So hopefully that all kind of makes sense about, you know, how we're reading that and what we're looking at there. The other question, or one of the other questions he had, was about this, the TR here, or the what this is specifically is it means a transformer rectifier. You'll also hear them referred to as TRUs sometimes, transformer rectifier units. And all that does is it converts AC power to DC power, and that makes a lot of sense if you just kind of follow the lines here as the power is flowing through the system. So once again, these big main gens, I mean, they work off of AC power, but there's certainly other components of the airplane that need the DC power. So you need to have this means of kind of going, you know, back and forth both ways between converting DC power in some cases, but AC power in the sense of as they pass through these transformer rectifier units, and that's all those do. If you had there's another point in the system where we talked about this static inverter where you can actually go from DC power and invert it back to AC power. But you know, once again, another discussion for another day, but that's what the TR is there for, and that's what it does, that's what it stands for. And you know, I thought of something also, you know, during the point in time when I was thinking about discussing this, and you might be wondering, you know, well, why do we use AC power for most of the things in the airplane? This is a good question. And you know, I've told you before, I'm not an electrical engineer, and I'm not, you know, completely, you know, well versed in all these principles here. But you know, very very generally speaking, with AC power, a couple things. You have less power loss over a longer distance. So I mean, if you imagine like all the like hundreds and, you know, maybe probably thousands of feet or yards or whatever of electrical cabling that you have like running through an airplane, these are very like long distances. So you have less power loss as the power is transmitted over those great distances with an AC system. But also from a heat standpoint, with DC currents, passing this much power through the system creates a lot of heat. And that's of course, you know, a fire hazard for us, and we want to mitigate that as much as possible on airplanes. So with an AC power system, you don't quite have as much heat generation as we pass the power like through the system. So just a couple things to make mention of there that you might be wondering about. And one other thing, you know, while we're here talking about it, just these IDG temperature indications down here, these are kind of interesting. You might just be wondering, well, what are those? And that's just it's the IDG oil temperature, actually. I mean, you kind of talked about this in, you know, once again, a previous discussion, but remember that we're, you know, we have a means of cooling down these IDGs through circulating fuel, actually like cold fuel when we're flying around, through this, this system that they devise, which actually cools that oil and keeps the IDG cool itself as you kind of recirculate the once hot oil, which gets cooled down, which then circulates again through the IDG to kind of keep the whole system happy. So that is all that I've got for you today, guys, on the air conditioning system there. So hope you enjoyed our discussion. As with always, if you have questions, please write in. It kind of helps fuel the channel here, and I'm trying to build this up, make this more interesting for you guys. So if you like what you see, please like the video, subscribe. It kind of helps just the YouTube logarithm, I guess, and it'll keep the community growing here and keep the discussion going and keep this fun for everybody. So once again, I really appreciate you tuning in. I hope you have a great week, and we'll talk to you again soon. Take care.